name of the topic which I will present it is Venn graph generator. So these are the contents which I will present one by one. So I start from the introduction of Venn graph generator. After that I will discuss little bit history of Venn graph generator, then principle of Venn graph generator. After that I will also discuss the construction and working of Venn graph generator. Then I will also discuss one research paper which are related to Venn graph generator, and after that I will discuss their limitation, application, safety, and at the end I will answer your questions. So let's come toward the introduction of Venn graph generator. Venn graph generator is such a device which generates a high voltage by means of an endless belt, collecting electrostatic charges from a source and transferring it to a large isolated dome shape on which a large charge accumulates. So here I use the word endless belt. It means that I construct the belt for Venn graph generator such like which have no end, like circular shape. After that I use the word electrostatic charges. So it means that we electrostatically transfer charges from one part of the Venn graph generator to the another part. And here also I use the word isolated metal dome shape. So we accumulate all the charges on or store all the charges on isolated metal dome shape structure which have circular shape. Why it have circular shape, I will also discuss it in the construction. And so now let's come toward the history of Venn graph generator. So the Venn graph generator was developed officially in 1929 by physicians Robert J. Venn Graaff, 1901 to 1967, at Princeton University on a fellowship with help from one of the colleagues, Nicola Gorky. Actually, after hearing about Ernest Rutherford's work in nuclear physics, Venn Graaff began to find a way to accelerate particles to very high speed in order to disintegrating atomic nuclei. So after the first model was demonstrated in October 1929, which they created a difference of 80,000 or at that time. After later version were constructed, it means that after too much time they were able to make differences of 1 billion or and 7 millions of. So it looked like that on Venn graph generator we can create a huge amount of voltage. So now let's come toward the principle. So this is the principle of Venn graph generators. Venn graph generator work on coronal discharge. What is coronal discharge? Coronal discharge is the discharging action of charging points. That is, electric discharges take place in air or gases radially at pointed conductor. And the charged conductor is brought into internal contact with a hollow conductor. All of it charges transfer to the surface of the hollow conductor and scattered uniformly over it, no matter how high the potential of the latter may be. So this is the construction of Van de Graaff generator. We use the moving belt. So these are the apparatus or the parts of Van de Graaff generator. We use the moving belt. So this is the moving belt which move on pulley. So these are the pulley, two pulley which we use here. So comb of needles. So these are the needles which are used for sprinting charges onto the belt or collecting charges from the belt and transferring the charges from the comb toward the dome shape sphere. So these are the dome shape sphere. Roller made from acrylic glass. So these are the rulers which is made from the acrylic glasses, and electric motor. So these rulers moving through the electric motor. Electric motor is nothing but it is such like a motor, look like sewing machine motor. So this is the working. So how it works? So let's discuss the working of Van de Graaff generator. So these are the construction of Van de Graaff generator. So here these are the combs. So electron jump onto the belt at the bottom. So here the electron come from the source and jump onto the belt. So as these belts are moving through electric motor, so the charges will be moving upward. So when it reaches at this region, so this comb collect the charges from the belt, and so it transfer toward the sphere, dome shaped sphere. So all the charges will accumulate on the dome shaped sphere. So these from here the electron jump off the belt at the top, and these are the concern. The rubber belt moved by a pulley rubs against the comb of needles. These needles stretch some electron away from the belt, as I already discussed, leaving positive charges on it which are collected by another comb of needle at the top. This top comb is connected to the metal dome on which the charge deposits. So these are the metal dome, and on this all the charges are deposited. So here mostly you see that whenever you place your hand on the dome shaped sphere of the Van de Graaff generator, so your hair will be get straight, look like this where you are watching. So why this happen? So actually here if you see to this figure, she placed her hand onto the Van de Graaff generator. So one question is also come in your mind is that why she not get shocked by placing hand on this Van de Graaff generator. So actually Van de Graaff generator create millions of voltage, but it also generate current, but that is in a milliampere, and you know that any person gets shocked by electric current. So here if the Van de Graaff generator is such that it generates a huge amount of current, so whenever she places her hand onto the Van de Graaff generator, she gets shocked. But here, as you know that Van de Graaff generator is such a generator which generates a very less amount in a milliampere current. So that's why she never gets shocked when she places her hand on the Van de Graaff generator. So as you know that I discussed in the construction that all the charges accumulate on this whole dome-shaped sphere. So whenever she places her hand onto the Van de Graaff dome-shaped sphere, so all the charges will be transferred on this path. So all charges will be moving and it reach on the air. So here, these are the air. So here each and every here take same amount of charges, same charges. Here this part of the hair take plus charge, and similarly this part of the hair also take plus charge. So that's why we know that the same charges repel from each other. So that's why each and every hair start repelling from each other. So that's why your hair will be look like this, and here also same charges repelling from each other, because all the negative charge repel or all the positive charge repel from each other. So that's why it will be varying in the air whenever you place your hand on the Van de Graaff generator. And also one more thing which I forget in the working block is that the method of charging is based upon the triboelectric effect. And triboelectric effect is such an effect that simple contact of dissimilar material causes the transfer of some electron from one material to the other. So this is the triboelectric effect. Now let's come toward the research which done on Van de Graaff generator. So actually this research was done by a scientist of Bangkok who do research on Van de Graaff generator and find the following relations. So these are the following relations which he find it. So E is equal to V by D or D is equal to V by E. So V is equal to K Q by R. So here the K is nothing, just constant, and Q is the total charges which accumulate on the dome-shaped sphere. D is the distance, R is the radius of the outer terminus, which always remain constant. So therefore, if we substitute this equation into the equation 1, so we get this equation. And here we know that E is equal to 3 multiplied by 10 power 6 volt per meter. So this is the graph which I take from that research paper. So this is the graph of relation between speed of the belt with the maximum discharge distance. And speed of the belt is nothing, just number of cycles per time or per second. So these are the limitation of Van de Graaff generator. The first limitation is that it produces very low intensity of current as compared to voltage. The second limitation is that it maintenance and construction is costly and bulky. The third is that per year a maximum of 3 million volt can be generated, as after that year will ionize. The fourth limitation is that it can't accelerate neutral particles. So these are the following applications. The first application is that in modern time the application of Van de Graaff generator is largely limited to academic purpose to demonstrate the particle aspects and concepts of electrostatic behavior of particles. The second application is that the primarily designed as a particle accelerator. The Van de Graaff generator are used in laboratories for demonstration purpose only. Means that most students use it in laboratories. So the third application of Van de Graaff generator is that the beam of these charges accelerate particles is used to trigger the nuclear reaction. The fourth application is that accelerated particle beams are used to break atom for various experiments in physics. The fifth application of Van de Graaff generator is that in medicine, such beams are used to treat cancer. So these are the safety factors of Van de Graaff generator. So first safety factor is don't allow students to use the Van de Graaff generator unsupervised. The second safety factor is that because people with cardiac pacemaker should never operate the Van de Graaff generator or come in contact with. This third safety factor is that obviously we are dealing with high voltage here, so stay about 3 feet away from the collector while it is charged. So you must take care whenever you are performing any type of experiment on Van de Graaff generator. The fifth safety factor is that always discharge the collecting dome between experiments and when they are finished. So these are the dome-shaped collector through which we discharge the whole metal sphere or the Van de Graaff generator. Don't run the generator continuously for a long period of time because then it loses a lot of heat that could damage the belt or the motor itself. The sixth safety factor is that keep the entire device clean and dry. It means that no impurity, moisture, because if moisture is present then it do short circuit. The seventh safety factor is that handle the aluminum parts with care in order to avoid electric shock. So these are the references from which I take all these data for presentation. If you have any questions, so you put that question in the comment box. So I will answer your questions in the comment box. So thanks for watching and subscribe my channel for further videos. Thank you.